Welcome back to my channel. The holidays have kept me busy, but I did manage to write some code recently, and today we're going to talk about saving and loading. Actually, well, this will be a two-parter. The first part is saving. I haven't done the loading yet, but uh, so what you're going to see here is I have the items dropping. And then when I save, I'm going to save it every time I hit next slice or the next slice changes automatically. Open this corner, you'll see like a little notification saying that everything had been saved. Yeah, progress saved successfully. I can't remember if I showed this before, but yeah, I did add sound. I think I made a video on that. I don't like the sounds particularly. I'm going to adjust them in further things, but you know, nothing really changes from what I showed in the tutorialized version. I don't know if I showed up how to set up this blur either. It's been a while since I made a video. Anyway, but today we're talking about saving, so I'm going to continue on with that. All right, so let's go look at some code. The first thing I needed to do was I created a save class. Why is it not showing as? Oh, there it is. Tetracube save game. All right. So it's kind of weird how this is set up. But it seems like there's a couple schools of thought of how to do this. It seems like it may, like, best practice may have changed over the years. But based on what I read in the Unreal documentation is they say that asynchronous saving is recommended. It seems like it's possible to, so let me open up my other code here. YouTube. That. So what I've done in the past, when I wrote my own, like, I guess, engine, using a game dev library, what I did was I just kind of like serialized all of the classes that I wanted to save, and I would save it into like just a text or a binary format. Unreal seems to allow you to save in binary, so I'm pretty sure from what I read, there's a way that if I wanted to just save the entire player board actor, I could. I would just need to serialize it first and then use their like a binary saving system. But it while it is writing directly to memory, and then I think it writes from memory onto the hard disk, it still can cause like a hitch in frame rate or something. Whereas the asynchronous just kind of like does it with resources left over, kind of piecemeal. So you can kind of save and load, more of like an open world game handles it. There's also a way to just save synchronously without converting to a binary file format first. But that I imagine is even less performant and would cause even more hitching. So what I was finding online from like people in the actual community, what they were saying is that you can create like a struct, and in that struct put in the information that you need to regenerate the asset the way that it was before. So it's a position. In my case, I'm going to have like the cube itself is just made up of a bunch of block actors. And all I really need is to know like what their position is, what slice they're in, and what the block type is. So it kind of makes this like really lightweight, because from there, all I have is an F vector and two uint 8s, and I made a T array of my struct. It does need to be a U struct, and it does need to be marked as U property. But I made a T array of cube structs, make sure that they are not pointers, and and then you just name it here. So when I'm saving out, I'm creating a whole bunch of these structs, adding them here, and then I have an array of uint8s for the queue, because all I really need to know is the number ID of the tetraminnow it is. From there, I can just regenerate it. And then I did the same thing with the hold tetraminnow. And then from there, everything else can just be, created from like what I already know about the player board and everything. So it's extremely lightweight, and I do like that. I did, just for the sake of this being reusable code, I did set it up to be asynchronous. Because I think, like, my next games are going to be more open world-ish, where I can like stream assets in and out. I'm going to want to be like saving data as it pops in and out of existence. And I think the only way to do that without like performance hits is with asynchronous saving and loading. But anyway, that's what the save game structure looks like. You just extend a U save game, call it whatever you want, and then the actual code itself, I probably should be handling this outside of the player board, but for right now, I just have like a save async function. A lot of this code here, maybe I should just be passing to the Tetris Cube save object. It wasn't particularly clear what best practice was in this regard. But right now I'm just handling it where I'm handling my gameplay, because it is going to be called like directly from the switching slice. What did I call it? Change active slice. That's what I called it. And so once I set up all that saving code, I just called save async here. Now, a couple of things that you need to know. Let's look over here so it's more highlighted. So yeah, so that was my .h file. That's all new. The menu pawn. Oh, I didn't have this in source control yet. That's interesting. Okay, we already went over that. The menu pawn, I thought I did all this in blueprints, but it looks like I did move it out to C++. Well, look at that. I can't even remember what all I've done. Right, so content, textures, source. There we go. Modified files. Now, part of the, an issue that I ran into was that once I create the tetraminnows, they don't exactly retain the information of what they are. I just, I have a bunch of blueprints on the player board, and then as I create them, add tetraminnow to queue. As I create them, I'm basically just getting a random uint8, and then based on the case, I'm spawning the actor. And from there, they already know what they are. They know that they're an I piece or a T piece or whatever. But if I need to load, I need to be able to save that. And I didn't actually have that save anywhere. So I had to add a uint8. I added some setter functions so that it would know what type it is. Then I could save that and regenerate them when they came back into existence. But in order to do that, I had to do these setters. And then I'm cascading the uint8 type down to the block level itself. So now the blocks and the tetraminnows, they have a uint8 telling them what type they are, so that when I reform them, or when I save them, I can just look at this value. I just called it block type here and tetraminnow type on the tetraminnow base. I can just look at that, I can save that out, and then when I load it, I'll regenerate them in the correct position and location and type. All right, so Let's go back over to source tree here. All right, so for the player board, I also realized that I didn't have any T subclass ofs for the actual blocks. I do all the block generation in the Tetramino themselves. So in order to just kind of like simplify everything and have it all in one place, I did add this here. I'm highly doubting that I did this in the absolute best way possible. I probably could have done some of this stuff and maybe like interfaces, make like a savable interface or something like that. Um, but you know, I just kind of wanted to get it working and figure it out. The whole point of this exercise for me is to learn Unreal Engine's save system. And then my next project will have better planning and I'll be able to look ahead and set up proper interfaces. But that is something to keep in mind in this particular instance. If you're following along, that's how I did it. I just made more T subclass of, and then I'm gonna put the different types of blocks in there, and then I'm just gonna do the same way I generate a new Tetramino. I'm just going to generate the blocks in play when I load using these instead. So this is what I was talking about before. The block base. I'm now keeping track of what slice they're in a public way. It was in there before, but I was just kind of passing it in from it wasn't being saved on the class level. So yeah, so now I'm keeping track of the block type and the slice that it's in. And then I moved this stuff from protected into the public section so that I could, you know, set it when it comes time. All right, Tetramino base. Yeah, this is just the setter that I already went through. And then the player board. There is some interesting stuff in here. So I just had I set the Tetramino type. I already showed that. But if you go down the save async, this is where the real like meat and potatoes is. So let's jump over in code base. Save async. All right. So I'm creating a new instance of a pointer of a Tetracube save game, and then you create the save game object using uGameplay statics. And what this does is it generates the type, you tell it static class, and it will return a U save game, and that's why you need to cast it. But it will retain all the information from a U Tetracube save game once it's cast. So if it is cast successfully, I'm setting up a delegate here. You don't, they do tell you in the documentation that this is optional. So I left the documentation from Unreal in here just to remind myself for the future. But all this is really doing is it's saying that after the save, whether it's successful or not, call this function. And this function has to have a signature of an F string, slot name, user index, and if it was successful or not. And I created that down here below. As of right now, all I'm doing is adding an on-screen debug message telling you that the progress was saved. I'm actually not even showing if it was successful or not. I probably should do that. But that's for later. I'll go over that in Monday's video when I go through loading and stuff. But yeah, so this specific signature is the only thing that can be bound to that callback. And this is how you bind it. But it's optional. I think something like this, in my mind, it seems like it's probably mostly just used for like alerting people that it was saved successfully or not, or like displaying the little rotating thing in the corner of the screen so that you know that it's auto-saving. I think that's the point of these. If I see other use cases for it, I'll talk about it in a further video. I might find it when I go into loading too. But from there, it's just building out my structures and adding them to the save game instance blocks in play. So I'm looping through every single block in play. I'm creating the struct. I just create a temp struct, and then I set the in play position that I'm getting from the block, the slice, and the block type that it is, and then I'm adding it to the blocks in play saved T array that I have set up. Same thing with the queue. This one's a little simpler since it is just a uint 8. I'm just looping through the entire queue, doing save game instance queue saved and adding it. And then this is something that I actually messed up on my first try. Make sure you put in a null check, because in this game, I know the queue is always going to be filled, and looping through blocks in play, if there are no blocks in play, this will just be a loop of 0. But for the hold tetraminnow, it's not a guarantee that there will be a tetraminnow in hold. So you will get a null reference exception if you try and save the value and by calling hold tetraminnow, get tetraminnow type. This will be null. So don't forget your null checks, people. And from there, you just kick off the kind of boilerplate async save game to slot. I'm passing in just a default save. The player index is 0, and the save delegate, and the save instance. So, actually, is the save delegate? Oh yeah, that's what I'm binding to. All right. So that's optional. Or, oh, maybe just the binding is optional, but you still need a saved delegate. So, or, well, unless, no, yeah, it has optional above the saved delegate as well. So maybe this here is optional as well. Oh yeah, it has a default. F async save game to slot delegate. All right. Okay, cool. Well, that's good to know. I learned something new since I put this together. But that about covers everything. So that's why you saw a saved progress saved in the corner. This will eventually be put into a little animation or something. And now it saves asynchronously, and I didn't notice any hitching when it actually saved. So yeah, I think it's working. The only other thing I want to bring to attention is I'm not sure about when it's actually exported into a project, but your saved games are under the saved folder in your Unreal projects. The project, there will be a saved folder and save games. This text here is the default save that I passed into the asynchronous save. So this default save equals this default save. If I were to change this, that name would be different. But that's where it's saving it to, and that's where it knows to look it up once it's all set. I'm wondering if, if you want to save it to a different location, maybe that's done through saved delegate. There might be more options on this, but right now I'm just doing it like in the boilerplate way. On Monday, I will go through loading and we'll test this out to know for certain that it's working. But so far, everything's been going fairly smoothly. I hope you enjoyed this video. I will see you in the next one.